Hello everyone, I'm Xiao Gang. Okay, in the last lesson, we created an ASC and a capability accumulation, but we don't have any abilities yet. Before we write abilities, we need to define some tags that we might use later. Since it's still quite functional, we need to define the tags now. Let's go back here, back to this place, and we should be able to just grab two of these. Let's see, we should be able to just grab two and create a new text file. Come here. Okay, we'll paste these two text files into this position. Then the file we are defining, what is it exactly? Actually, first of all, it is a gameplay tag. And also, our log channel. Log channel, let's do it like this. We'll process the logs conveniently. Okay, then let's paste it again. Paste it. Okay, good. Now let's refresh the project. We didn't directly write this capability. That's to avoid rework later. Let's just write it in the standard way. Good, then let's come here. We already have this log channel here. As for this log channel, it's actually just a definition macro, the log we've been writing earlier. Let's just code it directly. This defines the log. Then I need to explain this tag to everyone. This tag is quite important. That is, we need to create a tag. We need to create it using C++ because we will use it later. So first, we need to give it a namespace to make it easier for us to search. After giving it a namespace, we first write about. I'll just paste directly and then explain. And then this macro. What does this macro do? It defines some tags, and this macro defines these tags. Then a solid line needs to be added inside this red one. Just write it like this. Everyone can directly copy and paste. This is not technically demanding. Then let's go to our key, which is inside our tag. This is not technically demanding. I'll just paste it directly. Okay. Then this part is correspondingly converting these things into a tag. Nothing much to say. Okay. Then once we have the tag, sometimes we might need to find this tag by string. Find this tag. So we'll write a method here to search by this string, pass in a string and convert it to a gameplay tag. So how do we search for this string? It's actually written like this. That is, it gets the singleton manager of our gameplay tag. This gameplay tag cannot be dynamically changed. We cannot dynamically add or modify it. It is determined when the engine initializes. Then after this traversal, we request this tag here to see if we can retrieve it, right? Then if it can be retrieved, we will. This is where you hold on to this tag, and here is whether to perform this partial detection. That is, if you enable partial detection and it is not found here, that it is possible that you only matched a part. So it will also look for whether it is a partial match. If so, it will still give it to you here and log it for processing, prompting you that you are currently in a partial match state. Therefore, here, it may not necessarily fire. We are here. Generally, we need to not enable it. Usually, we do this accurately. Just such a match is enough. That's roughly the idea. There's nothing much to say about this. It's just converting a F1 into a tag. Okay, with it, we go to our character base. In character base, actually, to be precise, it should be in character. We need to activate this ability. Let's first take a look at how our original jump was implemented. Originally, we used jump and cushion. This jump was implemented. Here, for jump and cushion, we made a binding. When it starts, it will jump. When it completes, it will stop jumping. So here we need to make a change. We don't want it to keep using the original method. We need to write a method like his. So here, we put it down below. We write one, write two methods. Then here we bind it. Okay, then here, let's just do it this way. But after we finish this, we definitely won't be able to implement jumping because we haven't written the logic yet. Okay, here, we need to change this machine. Okay? As for these two methods, how should we do it? Because our approach here is quite special. First, we need to find such a tag. Here we need to include the header file. Let's put it below. It should be this header file. Okay, let's find this tag first. We haven't done the next step of the logic yet. Here we just get our tag, then we go to our AS. Obviously this is press. Is this release? We need to do this through ASC. So at the ASC, we need to write something inside. So when we press and release, let's write these two functions. So when we have this ability tag, when we activate it, input tag, note that this is the input tag. This tag is only used when we input. We will use it. So here we call it go into our getter. Here we can just pass this tag in directly. Let's check if we have this method. We should have this method. It should be fine. This is prompting that we don't include the same. Let's ignore it for now. Okay, this is prompting that the input tag has been released. We haven't written the specific implementation yet. We need to include the A4 header file here. It should be that one, okay? Good. Now it doesn't report an error anymore. Coming to these two methods in A4. What do we need to do in these two methods? Actually, here we need to prepare several containers. The purpose of these containers is to record the corresponding input world. Because you input into this tag, then during this period of time, the tag exists. When you release it, there is a corresponding release tag. We will process it later. Okay, this is equivalent to our input system. It serves as a link between the preceding and the following. Our input system is right here, reaching our center, reaching our ASC. This is what our input system needs to do. The next we need to perform a simple registration of our abilities. So, same as before, we go to our database. Now we need to do another part, because only when we put the ability in can you activate it, because we need decoupling. You cannot directly press the button directly, then just map this ability to the key binding, because this way it won't be decoupled. You won't be able to implement a key rebinding feature. Then come to our database. Then we write it to this position. Write it to this position. Okay, so how do we do it? Here we prepare a container. This container is also, we need to declare it forward. Declare it forward. This container also uses GameTag as the key, and its value as the specific ability. These abilities need to be registered. So we create a container here. So the abilities within this container, we can register after the registration is complete. We need to keep its handle. This is like after the ability is registered. The corresponding hand. And our blueprint doesn't really need to care about this handle. We'll just ignore it. In other words, we now have these abilities. Then during begin play, when we are on the server, we need to register these abilities. So how do we do this? Actually, we temporarily register abilities, because later we will read from a table. But we don't have time to make it for this level. You can normally read the table, because you have to do them one by one. That's more troublesome. Let's first iterate through our container. After iterating through the container, we get our CDO object. After getting the CDO object, we create a spec for the ability. Such a spec. What is a spec? It is essentially an ability, a spec for an activatable ability. We usually use specs for management. You can think of it as something like an instance of this ability, right? So here, we need to include the header file. Okay, so here we have created an ability entity, and actually its second parameter should be its in live, which is the level. We won't cover the level here. You can take a closer look, and its source object is this, meaning because it is ourselves, this AS itself, right? That is this ability. Is created from where, and especially this will be helpful for us later. And here, we need to add this tag to its dynamic tag. This tag is very useful. because this tag is actually our keys. It is our keys. After you add this tag, we will be able to know later which input tag it came from. Here we are using this input tag. Then with it, here we call this method of GameplayAbility to register this ability. You can see that here the ability is truly placed onto our ASC. Then it must have authority to be able to do it. Okay, and there are some interesting functions below here. There is one that activates when registering an ability. You can see there are also some blueprint ones here. We'll ignore them. Okay, this ability is now registered. After registration is complete, we need to record the actor we obtained. We add it to this actor. Yes. Add it to our container. That is, what things can we store? Okay, basically at this point, this is the process of initializing and registering our abilities. Then we go back to our AS right here. We actually process this tag. How do we process it? That is, we first need to determine whether this tag is valid. It could be an invalid tag. We call it one way or another. Then we iterate through our AVT. This is inside the ASC. It is actually a container of such a container because it will hold these registered abilities. Specifically, this thing is very useful to us. That is, we first need to determine the ability it points to must exist, and it has this tag, those that can match the tags. Then we consider it to be this. We then add it to our input system to be processed. Okay, when we release it, it also needs to be processed in the same way. So we need to determine if this ability is activated. We add it to the container we want to process. Just put it into these containers. We need to do a simple processing on it. Right? This should be not much to explain. Note this dynamic ability tag. Where does it come from? It is actually from what we just talked about here. This tag. So here, it matches up with what we discussed. So actually it is registered here first. After it is registered here, the tag of our input, it will then perform the corresponding activation through our actor. Our actor, right here, actor. It does a key binding here. This action, through this action. Here we do it. Here we go, back to our ASC. We look for, then we add a container to this container. How should it handle the next step? First, when we add a container, when drawing the tentacle, remember to reset it. It seems we forgot to call super here. Let's add the super for everyone. Just saw it. Okay, so we need to prepare a method here to specifically handle this ability. Let's write it here. This method is for handling the abilities we add to the container. Okay, so next let's also write a method to cancel these abilities. As for canceling, it's essentially just releasing these three containers. As for this handling, its call timing is quite special. Let's first write the internal processing logic. First of all, let's prepare one. Static. It's just a local static variable. Then we first put it down. We only use it temporarily within this scope method after putting it down. Here, we first check what tags we have. An input was made, so we first iterate through the tags we just added here. Then we go find it. Let's go find it. That is, whether we can find this ability, something called specific. Of course we can find it, because we are here. We find it, we need to add it here. It is only added after finding this thing. So here it is through finding it here. Yeah. Then we need to determine this ability. The ability pointed to by this must exist. This G must exist. After this GA exists, we set the GA's input price. Set it to true. After setting it to true, we directly call this method. Then we talk about calling this prices. We essentially treat it as activating such an input event. If it is not active, then here we may need to add it to this ability that is to be activated. Such a situation, let's include the same item. Okay, good. So this is the first part. We process these first. There is a tag like this. We have processed it. Okay, after processing is done, we will handle it here. That is to say, this ability, it does not, if it is activated, we just use this function. We haven't overridden this function yet. We will override it later for it to work. Here. Then if this thing is not empty, this means we need the ability to be activated. So we actually activate the ability. It is activated in this way. Only then do we activate it. Then after activation is complete, next we handle the situation where we have a key release. So for key release, it also first iterates through our container, then finds our GA's spec. Then we change this impulse to force. Then we call the release interface of the ability. These two interfaces are very important because these two interfaces involve a very important such an event. I will talk about it later. Okay, next, we have basically finished processing. We just need to simply close and release it. Okay, so here, what is this piece of code used for? It is actually here. We need to go into player control. We need to override such a method. Only then can it be correctly called. He needs to override such a method. So when input comes in, what do we need to do? We can just do it like this. First, we definitely need to call the parent class method. Then we get our ASC component. Here we need to include the component. Okay, it's still showing red here. It's very simple because here, this method doesn't exist yet. Since it's pre-control, the base class, I'll just do it all at once. Directly paste it over. Pretty simple. That is, we just need to obtain the corresponding components like these. These components are all made by ourselves. So after writing it like this, we won't need to keep casting. We can directly write cast code. We can directly through displays. Just do it. So first get this ASC. How is it obtained? Directly get its pawn. If this pawn exists, we can directly get this pawn. Okay, here we need a bunch of header files. We'll just paste this header file directly. Okay, good. This way it won't report errors. Good. As for the player state, we'll just convert its own player state directly. That should be fine. And this as X. As for the HUD, it's the same. We'll just take this HUD variable it owns. This is its parent class method. We'll just convert it ourselves. Then we input here. You can see the negative class comment here. We give a super. Let's go in and look at the comment for its negative class. It essentially means once there is input, it will process this method. Then by calling this method, we can process it in the ASC, a series of tasks we perform in the local container. Of course, here, our ASC also needs to add two more methods, because later we need to activate detecting when a button is held down, such an event. So we need to add two more methods. These two methods, we just need to place it here. These two methods are overridden methods. We can see here. For this kind of overridden method, we generally need to call the parent class. But whether to call the parent class specifically depends on your design in this situation. It needs to be analyzed on a case-by-case basis. Okay, so after executing the parent class like this, we can take a look at what this method does. Let's click it. It means it is called by our local player. And here we can do some input synchronization monitoring. And here we need to give this thing to it. Let's go back. Here, we need to synchronize this. That is, an event that needs to be synchronized will occur on our end. That is, we have pressed this button locally. That is, the button for this ability has been pressed. And here, we essentially need to synchronize an event. Therefore, at this point, we need to trigger this event. Only then can we implement a function where the ability is held down and not released, allowing continuous jumping. Okay, let's compile it. At this point, there should be basically no issues. In fact, this is the current execution sequence of this entire set of skills, with the first few steps all located here. Let's take a look at the package here. This package should be, it's equivalent to this handle. We didn't include the header file. Let's handle it. This header file issue. As for this header file, it should be this header file. Just paste it over. Okay, we're done writing. We finished writing it. Then we'll explain to you again. We'll write the specific content in the next lesson. The corresponding ability. First of all, we have a ASC component. This component, when it begins play in our character, it will, during the constructor, draw it out initially. After drawing it out initially, during begin play, we will take acquired ability and register it with it. Once it is registered, our player will perform an activation function. The player's activation function. We mainly use this cutter to set up an enhanced input binding here. When it is activated, we will have this tag. Use this tag to search within our ASC which ability it corresponds to. Because when we registered, we had this tag. You can see when we registered, there will be such a tag. Then with such a tag, it will find this ability. After finding this ability inside the ASC, it will add it into such a container. Then in our pair controller, every time an input system comes in, it will process this input system. Then when processing this input system, we need to find our ASC, handle the ones we added earlier. These abilities, the corresponding abilities, does it need to be activated? Because we only recorded which abilities correspond to which tags and they need to be activated. But whether they are actually activated or not, we actually don't know. Then we will make another judgment. If it is in this activated state, so we synchronize one for it. That is, there is this event, this impulse, this is still being held in such a held state. If it hasn't been activated yet, then we will activate it. If it is released, then if it is released while in the activated state, then we synchronize such a release event over to it. That's all. And finally, we clear this thing out. Okay, so that's the whole set. This GS inputs through this input tag, register and activate the ability. That's roughly how we write it. But we'll have to wait until we finish the first ability for everyone to understand. This section is a bit difficult. You can write it first, then later when we execute it, it will be clearer for everyone.